I got my first job in the space and satellite industry a little over 10 years ago, and that was at an intern at Boeing's SDC, the Satellite Development Center, working in the Space Simulation Lab. So there is where we would test units and just make sure that they would survive the space environment. So I applied for that summer internship just through Boeing's website, nothing fancy. But once I was there, I was able to build relationships and sort of get my foot in the door. So that once I graduated college, I was already in the system and I was able to turn that into a full-time position as a mechanical design engineer. I would bring that all the way back to a sort of fascination I've had with space ever since I was a kid. I used to have books on the solar system and the planets, and I used to love to quiz people on which ones were the gaseous ones, which ones were the terrestrial ones, how many Earths could fit inside the sun. I just always kind of had this fascination with NASA and the space race and all the technology involved, putting a man on the moon, just kind of followed me my entire life. So when I was in middle school, I used to give tours of the school planetarium. And then when I was in high school, I actually took classes in astronomy just for fun at the local community college. So when I went to college at Caltech, I was pretty much set on wanting to work on either satellites or rockets. So I got my degree in mechanical engineering. And for me, it's just always been about following my passion, and I've just always had a passion for space. It wasn't a super conscious effort. I kind of fall back on following your passions. When I started at Boeing, first job was as a mechanical design engineer. And to me, there was just nothing more fulfilling than conceiving a design in my head or on a whiteboard, modeling up, and then a couple months later, it becomes real at a machine shop and eventually actually gets integrated onto the spacecraft. And that kind of stuck with me my entire career. So in my next assignment, I became a subsystem REA, so Responsible Engineering Authority. So now I wasn't just architecting, single components, but now as an entire $20 million subsystem, with big giant 8-foot reflectors and hundreds of feeds and really large composite structures. But it was a similar thing, right? That process of designing it, and having it real, kind of womb to tomb, something I derived a lot of fulfillment from. So as my career has progressed, from design engineer to subsystem REA to subsystem IPT lead, and now as a program manager at Millennium Space, I've always gotten that fulfillment in my career from architecting a really complex system and turning it into a capability that improves people's lives or improves society or keeps our nation safer. So the tidbit I would give to the future leaders is really just kind of follow your passions. Because although you might be presented positions or opportunities that maybe they look a little bit better on paper, or maybe they have a little bit more flexibility, right? Or maybe they even pay a little bit more. But the amount of opportunities that are going to be afforded to you in the future when you pursue your passions, when you're passionate about what you're working on, is really something that you have to consider. Probably to network more. It's definitely an investment of time, and oftentimes you feel like maybe you don't have time to spend networking, but it definitely pays off. And I can think of a couple instances in my career where a lot of time and energy was spent trying to solve a problem when it turned out that a very similar problem was solved on a similar program. So I would say definitely spend the time to build your network. Because it does pay dividends down the line, and at the end of the day, it also builds advocacy within your organization. So spend the time to build that Rolodex. I think mentoring is definitely extremely important. You really should spend the time to pay it forward. Every successful person that I know has had great mentors. And it's really a way to accelerate your own experience, with the experience of others, especially people that you admire. So on the program that I run, even though it's a small spacecraft, it's roughly only a 2-foot cube. I have 16 subsystem REAs, so a lot of complexity in a small form factor, and I really make it a priority with each REA to spend at least one meeting per month with like a one-on-one mentoring session, so they can be afforded opportunities to realize their career ambitions. Biggest lesson I think I've learned in my career that I continue to learn is really that no mission is possible without a team. And thus, when it comes to the health and productivity of the team, that has to take precedence. And that means that every decision that's made can't just be within some absolute context of right and wrong. It really has to be within the context of, does this improve the productivity of the team? So I'd say that earlier in my career, I'll admit that sometimes I was quick to elevate issues, or sometimes, just find the fastest route to overcome what I perceived as an obstacle. But eventually I learned, and I think everybody learns, that really, if that comes at the expense of the team, right, that's completely overshadowed by the long-term benefit of having a team that has consensus, right, and that's aligned behind a common mission and common objectives. The small satellite market is roughly a $4 billion market today, but it's projected to become a $40 billion market in the next 10 years. So it's the fastest growing sector of the space industry. Millennium Space, we specialize in small satellites, and even though we're only a relatively small 400-person company today, we have a couple of different programs that are on the precipice of becoming really large-scale billion-dollar constellations, including the program that I run. So just last Friday, we were actually notified of award on a follow-on delivery order. So we're about to double the number of spacecrafts that we're currently on contract for, and we're hoping to double or even quadruple that again within the next couple of years. So there's a lot of growth opportunity. It's an emerging market, not just for Millennium, but for the United States. So with this emerging market, the United States has always traditionally had a technological lead in space, and that's something that we really need to maintain in the future. I kind of mentioned the space race before, but the truth is the space race didn't really end in 1969. It may not make as many headlines, but it's raging even today, not just with our traditional rivals, but also new rivals like China and India. So I think it's really important that we train the next generation of talented engineers to maintain that technological edge, to not only secure our futures, but also capture that emerging economic opportunity.